Hello. Please hit like button and subscribe my channel. Also press bell icon for future video notifications. Thanks.
Changes in Earth's orbit that favored hotter conditions may have helped trigger a rapid global warming event 56 million years ago that is considered an analogue for modern climate change, according to an international team of scientists. There has been a lot of interest in better resolving that history, and our work addresses important questions about what triggered the event and the rate of carbon emissions. The scientists analyzed core samples from a well-preserved record of the PETM near the Maryland coast using astrochronology. They found the shape of Earth's orbit, or eccentricity, and the wobble in its rotation, or precession, favored hotter conditions at the onset of the PETM, and that these orbital configurations together may have played a role in triggering the event. An orbital trigger may have led to the carbon release that caused several degrees of global warming during the PETM, as opposed to what's a more popular interpretation at the moment, that massive volcanism released the carbon and triggered the event, said Kump, the John Leone Dean in the College of. The findings, published in the journal Nature Communications, also indicated the onset of the PETM lasted about 6,000 years. Previous estimates have ranged from several years to tens of thousands of years. The timing is important to understand the rate at which carbon was released into the atmosphere, the scientists said. This study allows us to refine our carbon cycle models to better understand how the planet reacts to an injection of carbon over these timescales, and to narrow down the possibilities for the source of the carbon that drove the PETM, said Mingsong Lee, assistant professor in the School of Earth and. Those rates are close to an order of magnitude slower than the rate of carbon emissions today, so that is cause for some concern, Kump said. We are now emitting carbon at a rate that's 5 to 10 times higher than our estimates of emissions during this geological event that left an indelible imprint on the planet 56 million years ago. The scientists conducted a time series analysis of calcium content and magnetic susceptibility found in Earth's orbit varies in predictable, calculable ways due to gravitational interactions with the Sun and other planets in the Solar System. These changes impact how much sunlight reaches Earth and its geographic distribution, and therefore influence the climate. The reason there's an expression in the geologic record of these orbital changes is because they affect climate, Kump said. And that affects how productive marine and terrestrial organisms are, how much rainfall there is, how much erosion there is on the continents, and therefore how much sediment is carried into the ocean environment. Erosion from the Paleo-Potomac and Susquehanna rivers, which at the onset of the PET. This formation, called the Marlborough Clay, is now inland and offers one of the best preserved examples of the PETM. Of course, some of records are distorted and there are gaps, but we can use the same types of statistical methods that are used in apps that can determine what song you are trying to sing. You can sing a song, and if you forget half the words and skip a chorus, it will still be able to determine the song, and we can use that same approach to reconstruct these records. Timothy Brailower, professor of geosciences at Penn State, also contributed to this research. Other contributors were James Zakis, distinguished professor at the University of California, Santa Cruz, William Rush, a postdoctoral associate at Yale University and the Cooperative Institute for Research in Environmental Science at the University of Colorado Boulder, and Jean Self-Trail and Marcy. The National Key RD Program of China and the Heising-Simons Foundation provided funding for this work. Materials provided by Penn State. Original written by Matthew Carroll. Note: content may be edited for style and length. Mingsong Lee, Timothy J. Brailower, Lee R. Kump, Jean M. Self-Trail, James C. Zakis, William D. Rush, Marcy M. Robinson. Astrochronology of the Paleocene-Eocene Thermal Maximum on the Atlantic Coastal Plain. Nature Communications, 2022. 13, 1, doi, 10. 1038, S41467, 022, 33390X Penn State. Changes in Earth's orbit may have triggered ancient warming event. Science Daily, 13th of December 2022. ift.tt/Wadzua8y. Penn State. 2022, December 13th. Changes in Earth's orbit may have triggered ancient warming event. Science Daily. Retrieved December 13, 2022 from ift.tt/Wadzua8y. Penn State. Changes in Earth's orbit may have triggered ancient warming event. Science Daily. ift.tt/Wadzua8y. Access December 13, 2022. Thanks for watching. Please subscribe my channel for more videos.